Welcome back to Beyond the Orbit Files. Today, we're diving into a mystery that starts not with a discovery, but with a prediction on paper. The story of Neptune. 4.5 billion kilometers from the Sun, there's a planet that shouldn't have been discoverable at all. No one saw it through a telescope first. No one stumbled upon it by accident. It was found on a piece of paper, calculated into existence before a single human eye ever confirmed it was real. This is Neptune, and what we eventually learned about it turned out to be far stranger than anyone expected. Neptune sits so far from the Sun that it's completely invisible to the naked eye. For most of human history, we simply had no idea it existed. That changed in the 1840s, when astronomers noticed something odd about the planet next door, Uranus. Its orbit kept drifting slightly off course, as if some invisible hand were tugging at it. A French mathematician named Urbain Le Verrier ran the numbers and predicted that an unseen planet must be pulling on Uranus from a specific point in the sky. When astronomers finally pointed a telescope at that exact spot in 1846, Neptune was sitting right where the math said it would be. It remains one of the only planets in history discovered through prediction before observation. For over a century afterward, Neptune stayed a blur, a distant blue dot too far away for any telescope to reveal real detail. That wouldn't change until a spacecraft built in the 1970s finally reached it. In the entire history of space exploration, exactly one spacecraft has ever visited Neptune, Voyager 2. To even get there, Voyager had to take advantage of a rare planetary alignment, an arrangement of the outer planets that only lines up once every 175 to 200 years. Using the gravity of Jupiter, Saturn, and Uranus like a series of slingshots, Voyager 2 leapfrogged across the solar system until it finally reached Neptune in August 1989. By the time it arrived, the probe had been flying for over a decade, running on instruments that were, by today's standards, incredibly primitive. Basic cameras, filters to isolate light wavelengths, and sensors for infrared, ultraviolet, magnetism, and radio emissions. It flew within roughly 5,000 kilometers of Neptune's cloud tops, the closest approach Voyager 2 made to any planet on its entire journey. What it captured in those few hours is still, to this day, most of what humanity knows about Neptune firsthand. Neptune looks peaceful. It isn't. Winds on Neptune are the fastest ever recorded on any planet in our solar system, capable of exceeding 2,000 kilometers per hour, fast enough to break the speed of sound. For comparison, the most extreme tornadoes on Earth rarely pass 500-kilometer pitch. Voyager 2 photographed a storm system roughly the size of Earth itself, later nicknamed the Great Dark Spot, a swirling, high-speed vortex not unlike Jupiter's famous Great Red Spot, but angrier and shorter-lived. Later observations from the Hubble Space Telescope showed that Neptune's storms actually come and go over just a few years, unlike Jupiter's, which has raged for centuries. Here's what makes this genuinely strange. Neptune receives less than 1,000th of the sunlight Earth gets. It should be one of the calmest, coldest, most inactive places in the solar system. Instead, it's the windiest. Something inside the planet is generating far more energy than sunlight alone could ever explain. Neptune's outer layer is a thick atmosphere of hydrogen, helium, and methane. And it's the methane that gives the planet its striking blue color, since methane absorbs red light and reflects blue back into space. Below that sits something much stranger, a dense, slushy mantle made of water, ammonia, and methane, compressed under pressure that increases the deeper you go. At the very center is a solid core of rock and metal, roughly Earth-sized, but nearly 50% more massive. The pressure inside that mantle is estimated to reach several million times what we experience on Earth's surface. And under that kind of extreme pressure, something remarkable is theorized to happen. The carbon inside methane molecules gets squeezed so hard it crystallizes. In other words, scientists believe Neptune may be raining diamonds. These diamond crystals are thought to form deep in the mantle and slowly sink toward the core, generating fraction as they fall through the dense material around them. That fraction produces heat that eventually works its way up through the planet and into the atmosphere, fueling the supersonic storms we see from space. It's still a theory, one of the most compelling explanations we have for why an ice jar this far from the sun behaves like it's boiling with energy. Neptune has 16 known moons, but one of them breaks the rules completely: Triton. Nearly every large moon in the solar system orbits in the same direction its planet spins. Triton doesn't. It moves backward, a retrograde orbit, which is essentially impossible for a moon that formed naturally alongside its planet. The leading explanation is that Triplet wasn't born as a moon at all. It's believed to have originally been a dwarf planet, likely part of a binary pair orbiting each other far out in the Kuiper belt, the same distant region where Pluto resides. At some point, that pair wandered too close to Neptune. The planet's gravity tore the binary apart, flinging one object away into deep space and capturing the other, Triton, into a permanent, unstable orbit. That instability isn't just historical, it's ongoing. Triton is gradually spiraling inward towards Neptune, and in roughly 3.6 billion years, the planet's gravity is expected to shred it apart entirely, potentially forming a ring system that could rival or even surpass Saturn's. We won't be around to see it, but it means Neptune, quietly, is building its own future rings. For decades after 1989, Neptune mostly faded from view, too far, too faint, too easy to overlook. But in just the last couple of years, that started to change, thanks largely to the James Webb Space Telescope. In 2023, Webb managed something no spacecraft ever had. It captured a direct image of auroras glowing on Neptune, confirming activity at the planet's magnetic poles that scientists had only suspected since Voyager's flyby decades earlier. Around the same time, researchers went back and reprocessed the original Voyager 2 images and made an unexpected correction. That deep, saturated blue we've associated with Neptune for over 30 years turned out to be exaggerated by old image processing. Its true color is a much paler blue-green, far closer to Uranus than anyone realized. The two ice giants, it turns out, look far more like twins than we ever gave them credit for. Ground-based telescopes have kept adding to the picture too. In 2024, astronomers using some of the world's largest telescopes confirmed two new, extremely faint moons orbiting Neptune, pushing its total count over a dozen, both likely fragments of larger moons shattered by ancient collisions billions of years ago. And the mysteries keep multiplying. A recent study of Neptune's south pole found its temperatures have been dropping over the past 2 decades, despite that region technically entering its summer season, a pattern nobody can fully explain yet. Meanwhile, separate research into Neptune's smaller moon Nerea suggests it may be the last intact survivor of a much larger, long-vanished satellite system. Bit by bit, without ever sending another spacecraft, we're still learning that Neptune has more secrets than one flyby could ever reveal. Voyager 2's flyby happened in 1989. As of today, there's no active mission to return. NASA has studied concepts like Neptune Odyssey, a proposed orbiter that would spend years studying Neptune and Triton up close, potentially even dropping a probe into the atmosphere itself before it's crushed by the pressure. So far, it remains just that, a concept, competing for funding against dozens of other missions across the solar system. Until a new spacecraft makes the decade-long journey out there. Almost everything we know about the 8th planet still comes from a handful of hours in 1989, and a slowly growing trickle of clues gathered from millions of kilometers away. Neptune was found before it was ever seen, visited exactly once, and what little we know about it suggests a planet more violent, more strange, and more alive than its pale bluing-green color lets on. Subscribe to Beyond the Orbit Files for more deep dives into the mysteries of our solar system.